Okay, a little bit more progress on the rear side. So this is going to be the side that's against the wall. Put this power socket extender thing on here. It's just sitting on a couple of screws like that. There we go. And it's got separate switches, so I'll be able to switch off and on things separately. Might not be so important once it's up and running, but right at the beginning I want to be able to control things separately just in case something blows up. So this is going to be like the PC and the VFD, and then the power supplies for the stepper motors. And then over here I've still got 3 more which I might be able to use for a vacuum or a water pump or coolant pump or something like that. I'm not really sure. But they're all accessible, and I'll be able to reach across from here and turn them off and on like that. And then down here we have a piece of aluminium angle which goes all the way over there. And this is going to be to hold the drag chain for the stepper motor and limit switch cables, which are going to come out about here, and they're going to sit into this. So it's going to go like this, and it's going to go to about there, and then there'll be another sort of a bit sticking out here that the wires are going to travel up to from here. Haven't really thought about that too much yet, but it just needs to go along to here like that. I started making the holes for the connectors for the stepper motors and the limit switch plugs here, but my step drill doesn't go quite large enough, so I'll have to do that another day when I get the right tool for it. I was planning on putting these a little bit lower down, like about here, which is about the same height as the drag chain thing there, but when I was putting the panel in and out over here, I have to be quite careful to clear the side of this as this panel swings in and sits on the back. So those plugs there, as I've got them, are like right up about as far as I can get them towards the top, and that means that they're actually going to be slightly above this plate here, like about that level there, so that even if they do stick, because they'll stick out quite a bit into here, so the side of the case is going to be here, the plugs are going to be sticking out to about here, but they're going to be over the top of this plate, so that's why they're up so high. But kind of means that I can't really add any more for other stuff down here below unless I'll have to take the plug out every time I want to put that panel in and out, which would be kind of a nuisance, but at least with these 4 here I won't have to do that. Another reason to keep this area here clear is because I might possibly in future add a 4th stepper motor for a 4th axis, like a rotary axis or something here. So there's plenty of room for the stepper, but I wouldn't want those plugs to be encroaching on this area too much. So having them right up the top there is actually kind of good in that respect. These are the braking resistors for the spindle. These are optional, but what they do is when the spindle goes from a high speed to a low speed very quickly, it will have quite a bit of energy that it needs to dissipate somehow. And if you don't have these, what will happen is that the VFD will trigger an error, and you'll have to manually reset the VFD before you can use it again. You don't really need them, and I wasn't really planning on breaking the spindle, so breaking means you actively try and stop it as quickly as possible. Now, I don't really want to do that. I'm okay with just having it sort of gradually slow down when it turns off. But what I found is that if you are using the G-code to control the spindle speed, and even if all you're doing is going from a high speed to a low speed, it will still cause quite a lot of energy change in that. So I decided to add these anyway, and the manual called for 220 ohms, 150 watts. I couldn't quite get that in a single resistor here, so what I've used is 4 100 watt resistors in parallel and series. They're 220 ohms, but if you do parallel and series in a square like that, you get back to the original resistance. So it's still 220 ohms, but it's capable of 400 watts of energy dissipation instead of the 100, so that should be plenty. That's wobbling quite a bit. That's not going to be good enough, I think. Okay, I'm doing a little bit of testing of the x-axis here, which is the longer one that goes that way. It's all just sort of loosely fit together, like these pieces here are not actually clamped down, they're just sitting there, but because they're heavy enough they'll stay there to do a little bit of simple checks. This is looking pretty good here, and just running this test program here, which is going to be the actual it's this plate here, or it's one of these two plates here that I'll have to make eventually, and seems to be going pretty well. The main thing I'm doing here is I wanted to check that this system with these belts, or this belt with the pulleys and everything, is going to work. It's a bit slow there. It's just doing a very slow spiral down into the middle, and then we'll see some faster movement in a minute. But look at how quiet these are, and the belt is not fully tight, so it's it's not expecting it to be like slop free. But it seems to be performing very well. So I just wanted to do this check because this is one check that I was not able to do before. With these other axes I could do quite a bit of checking with the just by putting this onto the end of the ball screw and turning it to slide the axis along. But this one I couldn't really do that, so that's what I'm doing now with the actual stepper motor. A little bit of bouncing on that top piece of the belt there, eh? Might have to put a little baffle in between the two bits of the belt there, because see, the teeth are quite close together. We don't want those teeth to be catching. I've been running for quite a while at different speeds and I haven't seen it to be a problem, and I think that when that belt is tightened properly it will be even less of a problem. So I'm hoping that I don't need to put anything in there to keep them separate, but I might still do it just to be on the safe side. But anyway, I'm really liking how quiet and smooth these steppers are. They should be, because they're all... Oh, we had some fast movement there. They should... Yeah. They should be quiet, because they're all like specifically made for these motors. And I've set them on the default settings there with those pins or dip switches, and we're doing 4 times micro stepping, so that's 800 steps per revolution at the moment. It could probably go up to 1600, but we'll see how it goes. This axis here we have to be a little bit more considerate of speeds because we have a different size ball screw there, so that's a 10mm per revolution ball screw. And we have more distance to cover as well, so we want to keep that in mind. Whereas these other ones are 5mm and 4mm on there. After that I wired up the Y and the Z stepper motor wiring as well, now that I knew how long everything needed to be going through the drag chains and stuff. And I used this cable that I got on AliExpress. I really like this cable. It has a nice sort of a soft plastic outer skin, and then it's braided and foil shielded as well. And then inside that you have 2 twisted pairs for each phase of the stepper, and also some kind of rope stuff so that even if it gets pulled on really hard, it's not going to stress the actual wires too much. Yeah, and it didn't cost too much either. I really like this cable. It's just perfect for stepper motors. I got these aviation plugs, as they call them, from Banggood. I bought some on AliExpress that never turned up. That tends to happen sometimes on AliExpress. Fortunately, it has not happened to me with anything expensive, just little things like this, but nevertheless, I thought I'd just get them on Banggood instead the next time. It's mostly the waiting that's annoying, because you wait and it just never arrives. It's really annoying. Anyway, these are really nice. I really like those. These stepper motors that I have are able to be wired either in parallel or in series. So they have 8 wires coming out, and you can choose whether it's got the wiring diagram on there. I think actually the next photo is, well, it's all in Chinese, but you can see here the series one at the top is what we're looking at here. So it'll go into one, the red, then it'll come out on yellow, and then blue, and then like you join these two together, as I've done there, should have a yellow and a blue. Yep, thank goodness. And then it comes out on black. So it's going through the coils twice, but just coming in and out once from the controller, from the driver. And the other way to do it is to do it like that, so that they're in parallel. Now, a long time ago, like I said, I started this project like 6 months ago, and for some reason I decided to do it the series way. And just as I was looking at this the other day, I noticed that it says low speed here. This is low speed position connection or something like that. And I can't think why I would have chosen the low speed. Low speed, high torque, I think maybe was what I was thinking. Yeah, because you get either more torque or more speed one way or the other. I don't really think it's going to matter that much anyway, but this is the way I did it. This is a little bit more convenient wiring-wise. Is it? Yeah, it is slightly more convenient to wire up. Anyway, that's how I've done it. So that's Y and the Z motors there. This is just a photo I took to show a friend, I think, because it's starting to look like quite a serious machine now. This is the Z-axis ball nut, which I took off because I wanted to change the direction of it so that this plate piece was at the bottom rather than the top. And I tried to put a little plastic tube in there so that the balls didn't fall out, but it didn't work very well, and they did fall out. And I was kind of worried about this, and I put it off for a long time, but eventually had to do it because I needed to put it back on there. You can see it wasn't on there for quite a long time. And after having done this, I would say if the ball nut is a large one, don't be too scared to have to do this. If it's any larger than this size, I think I'd be perfectly fine with having to repack the balls myself again. The problem with this, though, is that it was quite small. So it's 1204. The inner core of the screw is only 9mm wide. So when you're looking in here, it's very difficult to see inside to see what you're poking around at. But I think a larger one wouldn't have that problem. So yeah, the smaller they are, the more you should be scared of having to do this, I think. Okay, I have the Y and the Z axes all connected up now. Well, kind of. It's just sort of dangling around there in a rough position. But I just wanted to check that the steppers were going to run properly and the drivers were going to run properly. And I've just been playing around with some speeds and rapid speeds and stuff like that, just to see how far I could push it. And seems to be going pretty well. Oh, there's nothing on here at the moment. I took that off because I wanted to turn the ball screw around, and then the nut, I wanted to change the direction of it. And of course the balls fell out, so I kind of put that aside, and I'll have to like reassemble it and pack it with grease and stuff later on. So just for now I'm using just a file that is a 4mm file, which is the same size as the end mill that was used to make this. So it's not actually doing anything, obviously, but it should be following where this piece is already. I think you see what I mean. Okay, I'm just setting up the Z-axis with the spindle on it there, and mainly I'm just doing this so that I can measure the length of the spindle cable that I need. But also this is the first time that I've had everything actually working and functional here, and I was a little bit worried about this. It's very, very close there. It's not touching, so it does work if we just run it a bit. Seems to be okay. So everything's alright, but all the same, I think in the actual one, when I build it for real, I think I might try and put some sort of a divot or a little channel there, so that it's not going to be quite so close. Might be a safer thing. Just playing with the maximum speeds for this now. I think that will work. That's almost 4 kilos, that spindle. So this motor here seems to be doing the business just fine. After that, I connected up the VFD and I also added these circuit breakers in here. Now, I'm not sure if this is really ideal because they're 10 amp circuit breakers, and I have mains wire coming in to each one of them. One is for the stepper motor driver, the power supply is up the top there, and the other one is for the VFD. But the thing about that is that it could potentially allow 20 amps total to flow out of the mains, whereas the mains system here is supposed to be only going up to 10 amps. So it may perhaps be better just to have only one of these so that it would trip at an earlier current than the 20 amps. Or these don't actually trip at 10 amps, I found out. They can go up to like 5 times as much as that. So I'm really not sure if 2 is better than 1 here. Maybe I should have just had 1. But what I like about this is I can switch these separately here, and I can also switch them separately at the extension panel thing that I have on the side of the bench with the switches there. So there's lots of places where I can switch them, and I guess if something goes wrong, this will let me see which one of them went wrong, rather than having just opening it up and seeing that this is tripped and not knowing what happened. So anyway, let me know if this is a dumb idea and maybe I should just use one instead. The other thing I don't like too much about this is that we have the live wire coming in here, and for this one that goes up to the stepper motor power supplies, I just broke it out of the main sheath or whatever there, and then it continues on the other side there where we can't quite see. And this one here, obviously you can see this one a little bit better what's happening there. But this one likewise, just from the back of this one, continues around on this yellow wire to become, so this yellow wire is would have been the brown one there. I didn't have any brown wires to use for this, so yellow is becoming brown going into live on the VFD over there. What I don't like about this is that if these screws here were for some reason to back off a little bit so that this wire wasn't being clamped quite so well, for this one in particular, gravity would pull it down a bit, and this live wire might start touching things here, which is not great. So in the future I will definitely want to support this a little bit better somehow here, so that even if this screw comes undone, it's not going to slip out all the way to touch things here. This one's probably not quite such an issue because it's held at the top as well, but nevertheless if this backs out, it could potentially, I think it's long enough to touch things there, so that's probably not very good. This here is the star point for grounding everything. And since I have 2 of these separate wires coming in from 2 mains cables, I put the ground for both of these to that, and I don't think that's causing a ground loop. All that is doing is causing parallel, like we've just got 2 wires going back to the ground at the switchboard instead of 1. That's not a ground loop, right? Correct me if I'm wrong there. So this is the VFD end of the spindle cable. Now this cable, I think I have another photo of this somewhere. Hang on a second. So I'm using cable like this here, and I thought that this was foil shielded as well, but it's not. However, the braid shielding is quite a more substantial than the other one I had, so I'm hoping that it's going to be good enough. Anyway, let's just go back there. So I have the red, black and yellow are going to be the phase wires for the three-phase of the spindle motor itself, and then this green is going to be ground going to the body of the spindle, and then this one here is also going to be ground, but that doesn't get connected to anything at the spindle end. So what we're looking at here is the VFD end, and then this is just sort of RF shielding. It doesn't get connected to anything at the spindle end. So this is the spindle end. These two screws here I found are connected directly to the chassis of the spindle, and they are grounded, or they can be grounded, so that's what I decided to do. I took out one of the screws there. It doesn't really seem to be needed to hold things in much because it's got these other ones holding it in. So I just replaced that with a different screw and some nuts here, and at this end I use that as my earth. It's a little bit close there, but everything's really tight. And you can also, oh, this is the VFD end again. When you put this cover on there, I don't think it's going to get bumped around or moved, or I don't know. What do you think? Is that okay? It's probably like about 2.5 millimeters here, but this is earth, right? So I mean, what's the worst that can happen if one of these spindle motor phases hits earth? I don't know. So this is not really my area of expertise, but I'm pretty sure that will be okay.